Hello, welcome back to another video of learning Zig through Ziglings. For those of you who don't know, Zig is a pretty cool new programming language. I shouldn't say new, but it's new to me. It's a pretty cool programming language, and it's particularly meant, among other things, to do systems programming, but it is touted as a general purpose programming language. I'm trying to learn Zig by following this really fun um, set of exercises made by Chris Bosch. And the idea is on solving these fun little program puzzles, we will eventually have a good understanding of Zig. Yep, let's dive right in. Previously, we were looking at errors and the differ statement as well as the error differ statements. We understood its utility, the use case, and how they allow us to write code that is not only expecting success every single time, but also captures and handles errors and errors as a value type, which is an important real world scenario. Now let's move on to the switch statement. Seems pretty straightforward. A statement that we've seen in most other programming language. Let's see how Zig does it. Cool, let's dive right in. The switch statements lets you match the possible values of an expression and perform a different action for each. Yep, that makes sense. Here's the syntax. We have the switch, we have the expression here, and we can match it against a list of possible values. Essentially, switch statement is very similar to if-else ladders. Honestly, I'm pretty sure anything in if can be written in switch, at least in other languages, with some caveats, because we call these case statements in like C#, and there are certain caveats as to what these values can be. Now let's see how Zig does it. Yep, again, this saying it's equivalent to writing an if-else ladder, which we see here. If-else ladder, for someone who doesn't know, it's essentially you have if, you have an else if, another condition and what to do, and finally you have you can have n number of else ifs, and you finally have an else. Essentially, it's a whole bunch of branches that the code can take, the code can take depending on the conditions at that point in time. Cool, let's look into the code. We have imported the standard library here. We have the main function. We have a list of characters, it looks like, language characters, which is language characters, but seems like they are all integers and unsigned integers at that of 8 bits. We're running a for loop. We've seen this syntax before. This is the for each syntax. We're passing in a switch, and we're switching on each of the characters, and depending on where they stand here, the corresponding print statement is executed. This sort of syntax looks very functional like, similar to how the shorthand arrow functions are returned in JavaScript, sort of like a lambda expression almost. But yeah, it's quite similar to the other programming languages too. Let's see what the issue is here. Okay, it's saying, yeah, we're skipping some stuff here. That's okay, because for the purposes of the exercise, we're going to make these assumptions. Secondly, switch statements must be exhaustive. There must be a match for every possible value. Please add an else to this switch to print a question mark when C is not one of the existing matches. That brings up a good point. Let's clear the output. We'll do a run to see what the error looks like. Perfect. Now the compiler is saying, hey buddy, can't really compile this program because switch statement needs to handle all possible values of this particular data type. Since we cannot realistically write every potential possible values for most types, for some user-defined types like I'd say enums or something like that, like the error type, it's more reasonable. But some of the other built-in primitives like unsigned integers, like are we going to write for unsigned integers, are we going to write every single possible values from 0 to max? Not realistic. So what we generally have here is we'll add a default case, which it looks like in Zig, the syntax is very consistent with if and else. I kind of like that actually, because in usually most of the languages, I'll deviate to that later, but um, um, let's appreciate why how the default case is written, which is else. And what we're saying here is standard debug print question mark, and we have no arguments, so we'll just pass in this anonymous type. Cool. Right, perfect. I'm gonna clear, let's run the output. Yep, now you have Zig and question mark, which maps with 26, 9, 7, 42. 42 doesn't have a match here, so question mark is displayed. Perfect. I think it's pretty straightforward, but just so I can appreciate this particular syntax, especially the usage of the keyword else. Let's look at how switch statement typically looks in another language. Say in C#, we'll say var number is equal to 15 or something like that. We can have switch number, we open and close brackets, and we say case, and we say 1, and simple C# example would be console dot write line, and we'll say we the best. Similarly, we can have case 2, console dot write line, we the second best, right? Yep. Another thing we'll add here is again the break statements, because we don't want a fall through to occur. And we finally have a default block. Invalid entry. And obviously for default we wouldn't need any sort of a break here. Essentially the way it works here is by default in most languages, when number matches the condition, not only does it do this, it immediately goes to the next one and evaluates this as well, and then it evaluates everything down the order. But default is only evaluate, and this whole thing is called a fall through in other languages, which means by default that switch statement there is equivalent to something like this, right? And the important thing in Zig is by default it looks like the switch is equivalent to if and else if ladder, which means that when the first one is executed, it will not automatically fall through to the next one. And that's something that's really smart. I know Um, if my memory serves me right, even Swiftlang has something like that. A lot of the modern maybe Go does too, if I think about it. Uh, but all in all, I think that's a good thing because we don't want this sort of a fall through to happen because it's just this sort of a fall through to happen because it's just added cognitive overload when you're writing code. This is effortless syntax. Secondly, rather than using the word default, Zig's usage of the else statement consistent with the if else ladder also makes perfect sense. I personally like the syntax a lot. Cool. Looks like we have another exercise with switch. Perfect. Let's jump into that. I'm going to clear these temp files, clear my output. Let's look at the next exercise. 31. We're making decent progress there. Barely a couple of days, maybe a week ago, we started with the first one, and we're at 30. Out of curiosity, let's see, there are 100 exercises in total. That's good. That's good. That's good progress. Um, let's take a look at this. What's really nice is that you can use a switch statement as an expression to return a value. Perfect. This is again very common in most languages, including C sharp. Usually for these um, very verbose expressive syntax, there's usually a corresponding shorthand notations wherever it makes sense. And switch is one such example, similar to the try catch block that was there in Zig. Switch is a good candidate, and it's a very common pattern in most languages where you take the most reused form and say, we'll give the expressive form for certain developers who like it, but we'll also have a shorthand that makes code much cleaner, especially in very small comparisons, for example. Yep, that makes sense. Now let's look at this. All we're doing here instead, okay, an expression to return a value. Yep, makes sense. It's just as this switch here. Instead of performing an operation, we're going to say whatever value is compared. Let's just do a straight return, but we're not going to use by default it's going to be returning a value. Again, very similar to JavaScript, which is what I meant, where we don't have to explicitly write the return keyword here. It just signifies it's a return, and it's an expression. It knows that because we're assigning it to a value. Cool. Let's look at the code. These are pretty straightforward. We have an array of unsigned integers. We're doing a for loop again. Oh, it's just literally the same example. But instead of directly displaying it, we're assigning it to a real character. There is no else block here. Cool. Let's run this before we make that quick change. Should say again, quite literally the same thing, that all possibilities need to be handled and it's missing. We'll come here now and we'll say else exclamation mark, like how it asked. Clear it. Let's run the exercise. Perfect. Now we have the value being displayed. Just to compare and contrast these two things. We see that the initial expression is pretty verbose. It's expressive, Also, we're not assigning the value more. Let me correct myself. I think I spoke a little too early there, even a couple of minutes ago. By switch expression, what I mean by verbosity isn't really the right way to put it, but essentially, instead of um, printing something or doing something like var, uh, let's do it outside. Test undefined, right? Oh, it's the keyword, I believe. Temp value. Instead of doing something like this, temp value is 1. What we want here is a multi-line statement, I believe. We need to scope it. That's right. Yeah, see here, we're assigning the value 1 to temp instead of doing assigning it here. What we could have done is something like this, which is a switch expression. Loosely equivalent, not the same in this case. It's almost like writing something like this and then assigning it a value. Yep, assigning it a value there. But yeah, nevertheless, I think it's a really fun syntax. Let me undo this. Makes a ton of sense. I appreciate the way it is, especially the design decision. Usage of the else keyword for the default value, as well as ensuring that by default there is no fall through, and it's an if ladder equivalency and not an if else equivalency. Cool, that made sense. We have a grasp on the switch statements. Let's take a look at the next exercise. Cool, let's see this. And maybe we can push through the quiz this time in the video. We might slightly go over the 30-minute mark that I had planned, but that's okay. I feel like doing quiz number 4 would be a good stopping point. Perfect, let's see this. Zig has an unreachable statement. Use it when you want to tell the compiler that a branch of code should never be executed and that the mere act of reaching it is an error. Oh, okay. This is interesting. This is something that I personally have not seen or used in any other language. I immediately understand this. I get it. I have sort of used it in a way in other language. Here's how I have used it before. Keeping aside whether it's a good programming standard, unfortunately, I have used something like this. So the way we would do is we would say if, take a C# code that accepts a payload of some sort, and we'll say public async task. Let's keep it simple. Let's actually, why not? Let's just keep it this way. Task insert to database, right? And say we have a payload of some sort here, right? Insert payload. N. Actually, let's give it a better name, payload. And in the comments, now this is how we C# has the ability to put multi-line comments this way. Just to give a quick overview, we'll define the payload here as a record class. And this will sort of make sense. Also, it's for my recollection, if I'm being honest. Say you have an integer value, num1. I guess we can have, make this a property instead of a field and say, yeah, you have a public setter, that's by default, and a public getter. Just a common pattern. I should have used the shorthand for by using the record constructor, but nevertheless. Cool. Say we have two values and we need to insert one of them to the database. We'll say both of these values can be null, but they can be null independently, and both cannot be null at the same time. Something that we can do here is if payload, the way we would do this is payload dot num1 not equal to null, and payload dot num2 not equal to null. Better way to write this. This is incorrect. Instead, I will say we can say something like if payload is equal to null, and both, say both are equal to null, then we'll throw new exception. Payload is not valid. Please ensure at least one number is not null. Right? Something like this. And in the else block, we will do insert into database logic. Essentially, we'll be writing these overly verbose blocks, which is nothing but a branch. And we see here that Zig has a simple shorthand way of doing something similar. Very much appreciate this. I think this is a good way to replace these bulky blocks of code which add up over time into short and sweet one-word syntax. Yep, that is yep. I think that's pretty good. Now let's take a look at the example. Here we made a little virtual machine that performs mathematical operations in a numeric value. It looks great, but there's one little problem. The switch statement doesn't cover every possible value of the unsigned integer number. We know that there are only 3 properties, but Zig doesn't. Make sense? Use the unreachable statement to make the switch complete. Or else. Okay, they're giving us a choice. They're saying either use else or the unreachable statement. Correct. So the values can be 1, 2, or 3. If it's anything other than that, we should handle it and placate the compiler and say, hey, if another branching due to condition happens, we can explicitly say that's an error. So it's not an unhandled value, it's an error. Cool. Let's run this directly first. We'll see what happens. Perfect. We need to handle all possibilities. First, let's placate using the method we already know. We're going to say here What's the initial value if the current value is 0? It remains the same. Nothing is done. Cool. So what we're displaying here is if it's not one of these three values, then nothing needs to be done. Another way to solve this is to use the unreachable keyword. The way that we would do that is unreachable. Cool. And the way we will test that is we'll pass in 99. Perfect. Wait. Did I do this right? An unreachable portion of the code was run. Let's remove this. Perfect, it works. So this is how the stack trace would look. If this ever got reached, it says, hey, unreachable code reached. Oh, panic, it's right here. Perfect. We've displayed the first 6 values, then a state of panic entered, which said, hey, the program has crashed, and it's giving us exactly why it crashed. It's because it reached the unreachable statement on this particular line number 39. Perfect. I think that's a very useful programming construct. Instead of having somewhat of the same block of code repeated across multiple areas, or even having helper functions to do things like this, having a native programming construct to handle these scenarios is definitely a big bonus. Very happy with that. Cool. Let's jump into the next example. Let me look at the time real quick. We're right around hitting the 30-minute mark. I'd still say let's push a little bit further. That way we can get through to the quiz. I really like the format that Chris Bosch has come up with. This way we're actually treating this almost like a fun little university course. I really appreciate the thought and effort with the quizzes. Perfect, let's jump into it. Exercise 33, let's revisit the very first error exercise. This time we're going to look at error handling variation of the if statement. Oh, okay, fascinating. So initially we have if, so we have our foo condition, and we're going to say it's a value. Foo was not an error. Value is the non-error value of foo. Else, oh, an error has occurred. Yeah, we were just talking about this from the perspective of C#. There's a condition here that throws in an exception. This is sort of something similar. The inverse of that to an extent, but we all get the point. Cool. Let's see. Cool. I think that makes sense. Foo was an error. Error is a value. Error is the error value of foo. Okay. We'll take it even further with the switch statement to handle this type of an error. If we have a condition, it should return a valid value. Else, if an error occurs, apply switch on the error. I immediately knew the second it said switch, it was going to be what kind of error was generated in the else block, and in switch, how do we handle this particular error. I think that's what the example will hold. Let's see. We have the standard library imported, public main function. Every time I keep saying public main function because um, I mean in C sharp we generally don't write it that way. We don't write public static void main because we do have top level statements now, but internally when it compiles down it does wrap it um, in the main class. But in Java especially, one of the first languages that truly clicked for me, um, public static void main is such a staple of the entry point. Um, so I do like that. Cool, we have a list of unsigned integers of 8 bits. We're running a for loop, and for each of the value, we're gonna first do a debug print, and then we're gonna say call this function number maybe fail, number maybe fail. Okay, cool. So either the value is returned, which is unsigned integers of 8 bits, or this particular error type is returned, error set, my number error set is returned. Cool. And if that happens, we'll do if on n. If it's a value, take this particular path. Otherwise, if it's an error, apply switch on the error, and we'll say if it's one of these values, do this. This is going to fail because switch is not taking into account if what if the value is too small. But I believe that's our exercise. Please add a match for too small here. Okay. And we'll print a new line character. Makes sense. Let's run this piece of code. Perfect. Let's fix this piece of code. We'll say what if the error type is too small. And we'll say print less than 4. And this, we have this anonymous list, I believe, list tuple, whatever that is. We'll look into that a little later. Cool. Let's run this. Perfect. That works. And we see that all of these conditionals are also correct, which means our program is logic is fine. But makes sense. Here it's not really the return type, but it's saying if on this number, if it is equivalent to this value, then take this path. Else, if it's an error and the error is type, if it's an error, how does it infer the type here? We switch on the error. Okay, cool. Oh, makes sense, because here, this is the type. This type could be either a value or an error. That's how it's inferring. It's saying if it's a value path, take this. If it's an error path, take this. And it looks like the value path is always going to be the if, but the error path is always going to be the else. Makes sense. Conventions and rules make sense. And if it's one of these errors, we can apply a switch statement and branch them out and say, what type of error are you? And for that, what sort of logging do we need? Example makes perfect sense. I think I've grasped the idea around it. Feels very, very natural. So a big thumbs up from me personally. Cool, let's end with a fun quiz. Thank you, Chris, for writing these quizzes. Let's read this. Quiz time. See if you can make this program work. Perfect. Solve this any way you like. Just make sure the output is my num equals 42. First, let me close this. Let me clear the output. Let's read it first, then we'll execute it. First, we have the main function. It's returning void, which means it's not going to return anything, but it can return an error of any possible type, which is why we have this exclamation mark before void. Cool. I also like that Zig forces us to write the error type first and then the actual value that the program returns. That's a good call out that I didn't really pay much attention to. But the fact that errors are designated as this should be handled first and it's in your face, even the type, even the return type, in the return type, I think that's really great. Cool. We have IO, which is the input output. I believe we looked into this at some point and said we'll circle back. Again, it was a struct. In it was a struct. Yeah, I believe it was something like that. Should I take a tangent? Maybe not. Let's trust the process. We'll circle back to it. Um, yeah, and we'll actually circle back to it. Cool. Let's look at the standard output writer, and all it's doing is again, we've done this before. It's looking at the standard library, the IO, going into the file namespace, saying we want to write to the standard output, which is typically on most systems just the monitor, and we'll create the writer, sort of like a constructor way of doing this in C#, but it's a function here, obviously. Cool. We're saying the writer writes to IO. Cool. Init.io. Appropriate default to implementation based on the target configuration. Debug mode will set up leak checking if possible. Okay, whatever that means. Don't want to assume too much. We have a long way to go. Let's trust the process. Cool. We have the standard output pointer here, which is again the reference of the interface is given, which means it's the pointer. My number calls this function that if it's false, it'll return a legal number. So this would never actually run, but it can throw an error according to the compiler, because it's one of the possible values. So something that we'll have to do here is the my numbers type is not actually U3, is U3 along with this error that we need to handle with if, else, switch, whatever we want. Let me just go and run this piece of code again. Number one goal isn't to just say we learned Zig, is to understand systems programming, and part of that is truly treating a compiler as a team. Perfect. Let's see this. First error expected. It's saying, hey buddy, you cannot define this like that. What we'll actually have to do here is maybe just remove it. That way it infers the type. Perfect. This still doesn't solve the issue, because we can't just directly print it. What if it's an error and not an unsigned integer? But let's run it, see what happens. Cool, it's saying a compile time error. We cannot print an error union. If it was just an unsigned integer, yes, it would have worked. But there's a possibility that it can be an error. Even though looking at this code, we'll never run into this error case, the fact that the return type signifies it and there's a potential of an error, you're forced to handle it. No magic here. Express it, be precise in your writing. I like Zig for that. Cool. Let's solve it in the most recent wave that we saw. Sorry, I don't know why I wrote try. We'll say if, and we'll say my num, and we'll say if it is a value which is an unsigned integer of 8 bits. I believe it immediately understands it. One of the things we'll say is, let's just print it. Standard dot, actually we have the standard output file right here. Where is this reused again? Oh, where is it reused here? Never mind, we don't have to really write it. What we can say is this. put it here. Try, otherwise it throws the error. Makes sense. And we'll say else if it is an error. We don't have to really switch on it, do we? Yeah, we don't really switch on it. Just for funsies, we can go ahead and say, actually, let's not even say an error occurred. Instead, I want to do unreachable. Would that be right? Yeah, not really expressive, but for now, I'll say just because we learned the keyword. Let's look at this. Expect, ooh, that is right. Again, I need to change my mind and not just think in terms of C# and this or JavaScript where there is truthy falsy values. We don't have that in Zig. Be precise. So we'll say if this is 42, that's when we want it to print. If it's not, the code goes to an unreachable portion and errors. My bad. Okay. I assumed in the previous example that the value would. Okay, let's call it value. We'll use the value semantics. Right. Actually, we don't even have to do this. The first if will, are we going to use it? No. What was the previous error again? My num. It's not a bool. Let's just discard it because I don't want to use it. And for error, we'll do the same. We don't really want to use the error. We're just trying to solve the program and understand if our approach is correct. It's saying cannot print error union without a specifier, but this will not be an error. We'll say num and we'll use it. That way we know, because what it was previously doing, it was trying to pull this variable. What we want here is num, which is the de-errorified version of num. That should work. Perfect, we got it working. Very good quiz. Made me think, made me understand it a little better. That makes sense. That now it makes a little bit more sense than even the previous example, where in this particular syntax of if else, if error syntax, right? Whatever, handling errors with if. We can take this error union value, which is error or a possible valid value, and we'll feed it through an if, and we'll use the syntax. And that will extract out, the if will extract out the non-errored value, whereas the else will have the error value, and then we can use that to handle our code whichever way we see fit. Yeah, this has been a very, very fun set of exercises. Really, really nice the way if works with errors, how switch can be used. Also the unreachable keyword, very, very fascinating. Yeah, even though I'm a little tired today, I feel like this kind of gives me a boost of energy. A really, really, really fun exercise. Again, I'm going to call out Chris Bosch, the person who put this repository of exercises together. He did a fantastic job getting people like me, building something that gets people like me to come in and enthusiastically learn the language. I still want to go over the Ziggy documentation. We'll do a separate series because I think this is also really, really well written. I just to call out, I really love that it's a single page thing. It's really great because say we want to print something, it's really helpful for that too. Really, really smart call making a single page documentation. Regardless, I think we can call the video there. We exceeded our 30-minute mark by 15 minutes. Seems to be a fun pattern that we're running into. But hey, can't complain. The language is so exciting that we're forced to learn more and more. But yeah, I'm going to call it there. I'll probably go over the next bunch of exercises very soon. But until then, thank you and goodbye.